Hello everyone, welcome to our channel Physics, where we actually learn physics. So in this lecture we are going to solve two problems based on the chapter Units and Measurements. Over here you can see the first question. Okay, later on we'll solve the second one also. So let's first of all read this question. The question says that the SI and CGS units of energy are joule and erg, okay, respectively. How many ergs are equal to 1 joule? Okay, so the question is pretty simple. We know that SI and CGS units of energy are joule and erg, isn't it? What is SI unit of energy? Nothing but joule, right? And what is CGS unit? Nothing but erg. So the question is, we have to find out 1 joule equal to how many erg. That's it. That is our question. So it's very simple. So for that, first of all, we need to know some data related to energy. Okay, we need to understand what is the unit of energy first of all. Okay, so for that, what I'm going to do is I'm going to use a simplest formula related to energy. Basically there are many forms of energy, each having different formulas. Over here I'm going to use a simple one, that is the kinetic energy. So we know kinetic energy is equal to 1/2 mv squared, isn't it? So if I represent this in terms of the base quantities, then it will be 1/2 m. What is v? Nothing but some distance divided by time, right? And it is whole squared, isn't it? So energy would be equal to 1/2 m x squared upon t squared, isn't it? Now from this we can find out the units of measurement of energy. Now in SI unit system, the unit of measurement of energy will be what? See, here you have mass, that means it is kg. Then this is x, that is some distance, so it will be meter squared, right? And you can see there is time in the denominator, it is squared, so it will be second inverse squared, because when it comes to the numerator it will be inverse, isn't it? Now in CGS system, the unit would be, CGS is what? Centimeter, gram and second, right? So in terms of these system, the unit would be, first is mass, so it will be gram. Then we have x squared, so it will be measured in centimeter squared, and this time squared, that will be second inverse squared. Okay, so this will be the unit in terms of CGS unit system. Okay, now the question is, what is 1 joule equal to in terms of erg? Okay, now what is 1 joule? So this SI unit, okay, 1 kg meter squared per second squared is called as 1 joule. Okay, and 1 gram centimeter squared per second squared is called as 1 erg. Okay, that is our question, isn't it? So we have to find out the conversion factor between the two systems of units. Okay, so what we will do is we will try to convert this. Okay, we will try to convert it. Okay, so 1 joule, as we know, is equal to, as I said, 1 kg meter squared second inverse squared, or 1 joule is equal to 1 kg into 1 meter squared, right? We can write it like this, into 1 second inverse squared. Okay, now let's convert this to CGS system. So we know 1 kilogram is nothing but 1000 gram, right? 1000 gram. Okay, then 1 meter squared. How can we write this? We can write this as 1 meter into 1 meter. That will be 1 meter squared into 1 second inverse squared. Okay, now let's write this. So this 1000 can be written as 10 raised to 3 gram. Then 1 meter. What is 1 meter in terms of centimeter? 1 meter is equal to 100 centimeter, as we all know. So it is 10 raised to 2 centimeter. Okay, into, again there is 1 meter, so it will be 10 raised to 2 centimeter into, again we have 1 second inverse squared. That's it. So 1 joule is equal to, let's see what we get. This is 10 raised to 3, okay, into 10 raised to 2 into 10 raised to 2 again, gram, centimeter, again into centimeter into second inverse squared, right? Okay, so let's write this. Let's solve this. 1 joule is equal to, how much it would be? 10 raised to 7 gram centimeter squared second inverse squared, isn't it? Or we can write this as 1 joule is equal to 10 raised to 7 into 1 gram centimeter squared second inverse squared. Is it? Now we know 1 gram centimeter squared second inverse squared is nothing but 1 erg, isn't it? So therefore we can write 1 joule is equal to 10 raised to 7. This term is nothing but erg. And this way we have actually found out the conversion factor between the SI unit of energy and the Cgs unit of energy, that is joule and erg. 1 joule is equal to 10 raised to 7 erg. Okay, so this is the answer to our question. Okay, now we will go to the next question. Here is our next question. The question says that Young's modulus of steel is 19 into 10 raised to 10 Newton per meter squared. Okay, Young's modulus is how much? 19 into 10 raised to 10 Newton per meter squared. Okay, now the question is, express it in dyne per centimeter squared. Here dyne is a Cgs unit of force. Okay, now we know Newton is SI unit of force and dyne is what? Cgs unit of force. So over here we have to convert Newton per meter squared into dyne per centimeter squared. Okay, and this way we will be able to find out the Young's modulus in dyne per centimeter squared. So the question is simple. Okay, see, y is given, it is 19 into 10 raised to 10, right? We can write this as 1 Newton upon 1 meter squared, right? Now we have to find out Newton, okay, in terms of Cgs unit system. That means we have to convert 1 newtons into dynes. Okay, so it's a very simple thing. Okay, let's go, let's do this. First of all, let's convert 1 newton. We know 1 meter squared, that can be easily converted. Okay, we know Newton is a unit of force, right? Force is what? Mass into acceleration, isn't it? Mass, okay, it is a base quantity. Acceleration is nothing but rate of change of velocity, isn't it? So it is dv by dt. dv is the small change in velocity, dt is the small time required. Okay, but again velocity is what? It is nothing but a derived quantity. Okay, now we know velocity is equal to what? The displacement, small displacement dx upon the time required for the displacement dt. Okay, in this way force can be written as m. Okay, when we do this calculation, it will be d2x upon dt squared. This is called as the double differentiation. Okay, okay, so from this we can get the units of force. Okay, so unit of force would be, if I go in SI unit system, the unit of force would be nothing but kg for this mass. Then here we have x, the distance, that will be measured in meter, and here you can see time squared, so it will be second inverse squared because it is in the denominator. So this is the SI unit system, right? Okay. Now in Cgs unit system, okay, Cgs is what? Centimeter, gram, second. In Cgs, the unit will be gram, centimeter, second inverse squared, simply. Okay, so this unit, kg meter per second squared, it is actually written as Newton. That means 1 kg meter second inverse squared is represented as 1 Newton. Okay, this is in honor of none other than Isaac Newton. Okay, now similarly 1 gram centimeter per second square is equal to 1 dyne. Okay, so we have these two equations. Okay, now we have to find the conversion factor between the two. Okay, so let's do this. So 1 Newton is equal to, as I said, 1 kg, 1 meter, 1 second inverse squared, right? Let's convert this to centimeter and gram. Okay, so we know 1 kg is nothing but 1000 gram. 1000 is 10 raised to 3, right? Gram into 1 meter is equal to how many centimeters? 100 centimeter. That means 10 raised to 2 centimeter into 1 second inverse squared. Seconds will not change because whether it is Cgs, whether it is SI, whether it is MKS, everywhere the unit of time is same, that is second. Okay, so 1 Newton is equal to this. Let's calculate this. This will be 10 raised to 5. You can see 10 raised to 3, 10 raised to 2, it will be 10 raised to 5 gram centimeter second inverse squared. Or we can write 1 Newton is equal to 10 raised to 5. We have just said here 1 gram centimeter second squared is nothing but 1 dyne, right? So we can write 10 raised to 5 dyne. So in this way we have got the conversion factor between Newton and dyne. Okay, now let's go to our main equation over here. Okay, here it is. What is the question? Question says that Young's modulus of steel is 19 into 10 raised to 10 Newton per meter squared. You have to express it in dyne per centimeter squared. Okay, so let's do this now. Here it is. We have just found out 1 Newton is equal to 10 raised to 5 dynes, isn't it? So let's find out. Y is equal to 19 into 10 raised to 10, okay, Newton per meter squared, right? This is the unit. Okay, I am deliberately writing 1 here because it doesn't matters, right? So y is equal to 19 into 10 raised to 10. Now 1 Newton is equal to how many dynes? Nothing but 10 raised to 5 dyne, and divided by 1 meter squared, right? It is nothing but 1 meter into 1 meter. Now we know 1 meter is equal to how many centimeters? 100 centimeters. That means 10 raised to 2 centimeters. So let's clean this up and just write 10 raised to 2 centimeter. Here also 10 raised to 2 centimeter. Okay, and finally if you see, y is equal to 19 into 10 raised to 10, okay, into 10 raised to 5, okay, then you can see this 10 raised to 2, this 10 raised to 2 will become 10 raised to 4. When it comes to the numerator, it will be 10 raised to minus 4. Dyne is the unit, and here centimeter squared, as you can see. So it will be centimeter raised to minus 2. Okay, now let's see what we are left with. Y is equal to 19 into 10 raised to 10, okay, Here you can see 10 raised to 5 into 10 raised to minus 4. So only 10 raised to 1 will prevail. 9 centimeter inverse squared. So y will be equal to 19 into 10 raised to 11 9 centimeter inverse squared. That's it. That is the value of Young's modulus of steel in dyne per centimeter squared. So in this way we have actually found out the value, okay, and we have actually solved both of the problems. Okay, so I hope this is clear. If you still have any doubts, you can ask me in the comment section. Okay, I will definitely try to answer as soon as possible. So thank you so much for joining. So we will meet in our next lecture where we will solve more problems like this. Okay, so thank you so much again. Bye bye. See you. Have a good day.